All right. Great. So today we are going to explore the topic Arduino in order to see how we can build STEAM projects by students. I shared with you on the chat two files for Arduino, level 1 and level 2. Those two files are PowerPoint, so you can explore them and use them uh, during your lessons. I'll try to open the first one by topic, Arduino level 1. All right. I have to share my screen, I think. Okay, share my screen.
اول واحد نزل.
Okay. All right. So the idea behind Arduino عم تشوف السكرين تبع باوربوينت صح؟
ايه عم شوف يس.
Okay, great. So the main question is why we have to teach Arduino for students and from which grade level? Uh, Before the establishment of the platform, the online platform tinkercad.com, usually it was like impossible for a teacher to offer or to teach students Arduino skills before grade 10. Why before grade 10 it was impossible? Because students are asked to build an electronic circuit, then to program it in a C++ language. So that's why the mission was impossible. But with the integration of the platform tinkercad.com during the Corona period, it is now possible, and you can see inside the curriculum 01 that Arduino is implemented starting from grade 7. But we have to distinguish between two part in Arduino. I mean, in grade 7, 8, 9, we have to follow a specific path or philosophy of teaching, which is by simulation. I mean, students are asked to work on tinkercad.com without building with the hardware the Arduino circuit. And starting from grade 10, 11, 12, students are asked to use the hardware in order to build Arduino projects. Since at your school, Al Etihad, it's your first year of implementation, I can advise you, even for grade 10, 11, 12, to start the introduction using the tinkercad.com platform. And I'll be showing you right now, after this presentation, how to deal with. And today, our presentation will include point A, discovering the 5 layers for teaching Arduino. B, skills and strategy for the Inspire category. No, sorry, excuse me. So actually, what we will be doing today is discovering the 5 layers for teaching Arduino. And the objectives of this workshop is to explore the different layers, as I said right now, and the audience should be the ICT teachers in general. When teaching a topic connected to a hardware like robotics, Arduino, microbit, 3D printer, printing, we always should take into consideration the 5 layers to connect it with the curriculum. I mean by layers, how we are going to split the curriculum in order to make it easy for students to understand better what you are doing as teachers. So and always when we are dealing with hardware, I mean, we as ICT teachers, if you remember well, years back, all what we were asked to give is like to teach them office, a little bit drawing, coding, maybe introduction to computer, for lower grades, how to save, how to print, a little bit Windows, but never students were exposed to touch and to manipulate a hardware in order to move forward for the STEAM education. But when we are dealing with the Arduino or the microbit or the robots, so here we have to understand more that there is a specific strategy that we have to deal with in order to teach it in a safe way. So we cannot open YouTube and learn from YouTube how to teach robotics or Arduino or other topics. We have to teach it in an educational way. So offering students skills in many subjects in order to let them create or reinvent a product or a solution for a problem, it is the definition for STEAM. I mean, when you as ICT teachers, you will be asked to define what is STEAM. Okay, so this is the definition. I will read it again. It's offering students skills in many subjects in order to let them create or to reinvent a product or a solution for a problem. And from there, we can move forward with this presentation. And before starting this webinar or this presentation, a major question should be asked: why we should integrate curriculum in the curriculum? And this question is really important, and it's a major question simply because if students are not convinced about Arduino, they will not accept it. So it will be rejected. So that's why you have an important mission as teachers to move forward with in order to attract them and to show them this potential that Arduino offers for students. So Arduino sorry, excuse me. Once you got the answer to the why, so you can proceed in a secure and confident way to explain for students the Arduino chapter. And the major obstacles for ICT teacher to teach Arduino is to get a solid background in electronics and programming in order to create projects. This is why hardware and coding concept will be developed during this webinar, and level 1 skills will be covered during this session. Level 2 will be done later in a later stage. So we'll start this webinar by introducing the word of microcontrollers in order to be able to find or to conclude the answer to the why we are teaching Arduino. And at the same time, we have to see the end point for each student reaching grade 12. What are, let's say, the skills that should be developed in ICT and robotics in order to make students understand tomorrow's world for a solid skills? And the skills that we are asked to offer are coding or programming, machine learning, artificial intelligence, and IoT, Internet of Things. And we offer those skills in an educational curriculum tested for more than 25 years. So I'll move forward with this presentation in order to give the definition of what is a microcontroller, because students should understand the word microcontroller and where this microcontroller is used. So that's why the word microcontroller is divided into two words. the micro which means small, and controller, which means it controls something. And a microcontroller, uh, a second question, where they are used. So here it should be a clear answer for students that a microcontroller is used in all electronic devices that we use every day, like the elevator, the fridge, the washing machine, the TV, the remote control, the car, etc. And why they are used. So this is a third question. So a microcontroller is used in an electronic device to control it for a better functioning. So when so here we can give an example. When the door of the fridge is opened, the lift or the light will turn on. And when moving more and more by exploring the questions. And here I really advise you to exchange those questions with your students in order to have an interactive lesson in Arduino. So the following lesson is or question is, who program the microcontrollers nowadays? So a microcontroller used in an electronic device is programmed only by the manufacturer. The user can never program it. So when we buy a new washing machine or a fridge or any electronic device, as users, we cannot change its functioning. We only can use what we call the programs pre-installed. So that's why we as users, we don't have this option to create or to modify the functioning of the program. And before going deep into the microcontroller definition and process, it is a must for you as teachers in order to go through the Internet of Things as definition, because without a microcontroller, the IoT will never be an option or will never see the light in all domains, in factories, in agriculture, in medicine, in services, in transportation, at home, everywhere. So this is why when you give the definition of IoT, which is the Internet of Things, which is the future technologies that will link every single device to the internet. So IoT will allow us to control by using an app those devices remotely. So and as we can see here on this slide, that the IoT is connected to give services to shops, airports, stations, IoT mobile devices, data centers, homes and buildings, cities, ships, airplanes and trains, factories, and other domain. And when we think about IoT, it's actually transforming each single electronic device to what we call a intelligent device in order to send data from the environment from around us in order to behave better and to find solution for pollution, for recycling, for healthcare, for manufacturing, and other problems that we are facing. That's why IoT is IoT will lead us to a world with less pollution, less consumption of natural resources as gas, electricity, better medical life, better production in factories and agriculture, less traffic, etc., etc. So from now, we can know that it is impossible to reach the IoT world without understanding the components of a microcontroller and how it functions. That's why the introduction to students to the world of microcontrollers is a must. And IoT as a solution is not possible to reach without the integration of microcontrollers in the devices to be connected. So what I mean by this definition, that now our fridge and washing machine is functioning according to a microcontroller built by the manufacturer, and we as users, we don't have this option to program those machines or those devices. So from here we can see that tomorrow devices will change, and we can buy and we can have a fridge, a washing machine, a car, where we as users can modify its functioning according to the program that comes with for many reasons, and to control it in a better way. The conclusion: after this brief introduction, it's now possible to answer why it's a must for students to learn how to control, how to program and work with a microcontroller. What we need in order to create an educational circuit to understand how to reach the IoT world: you need electronic devices such as sensors, motor, pump, screen, LED, push button, etc. And from here, we can go for more and more exploring this world. And teachers should keep in mind that input and output devices that are connected directly to the computer are limited to the keyboard, mouse, scanner, microphone, screen, printer, speakers, projector, etc., and that it is impossible to connect directly a sensor, a LED, a motor, a pump, a push button to a computer. That's why what we need is we need an electronic board, the microcontroller, that will play the role of linking the computer to all the electronic devices that could not be linked directly. And here we can explore the brands of microcontrollers in general. So for educational purposes, many brands are available on the market. Only two major brands leads. We have the Arduino. It's an Italian board dedicated for upper grades, starting from grade 7, and the Microbit, which is the British board created by the BBC, is dedicated for lower grades, starting from grade 3. And then why we have two microcontrollers, and what is the difference between them? So Arduino does not contain any input and output device, so it will be hard for lower grades who don't have any electronic background to build a circuit using Arduino. So that's why we go for the Microbit, which is loaded with a display LED screen for 25 LEDs, 2 push buttons, and 3 sensors. This will facilitate the learning process for kids in lower grades. And we have many examples of how to integrate Arduino in STEAM projects. So here we can see a parking gate managed by an Arduino in order to open and to close the door. We have another project with Arduino for a plant irrigation with Arduino. We have object detection. We have humidity and temperature detection with Arduino, and many other. So since this presentation is recorded, I believe you can take the PowerPoint slide I sent you with the essential of my lecture, in order to do it with your students, because believe me, if your students are not convinced about the importance of learning Arduino and what is the end goal of learning Arduino, they will never be attached or motivated for this topic, and maybe you will be facing some issues and problem regarding this issue. So when we move to practice, the hardware used to build a circuit and the software needed to create a program should be introduced to students. So this is why it's very important to split between the hardware and the software. And logically speaking, what we are going to start with is the hardware. Excuse me for just one. Sorry. So for the hardware, before working on the projects, uh, you have to know that students should master and know better what is the hardware that they will be using. So that's why we are going to show in the following slides some essential hardware that you are asked to manipulate. So we have the board, which is the Arduino board, and the board is essential for any project. It's used to link the input and output devices to the computer to perform a specific task. Another item that you will be using is the breadboard, and the breadboard is essential for any project to extend the connections of digital ports, since they are limited on the Arduino board, and we will be explaining this later on. We have the LEDs to create some lighting effect. We have the resistors that are essential to protect the electronic devices, especially the LED. We have the motor or the motors, which is considered as an output device to perform mechanical action. And here you have, let me update this. Sorry. So here you have, what's wrong? You have the servo motor and you have the DC motor. We have the buzzer to reproduce sound. You have the ultrasonic sensor, which is considered as an input device in order to detect objects and to measure a distance. You have the temperature and the humidity sensor, which is considered also as an input device to detect objects and to measure distances. Of course, you have a pack of 37 sensors for more creativity and more production of steam project. And I will limit this introduction for the hardware to move directly to the software. Here we have like two platforms that we are asked to explore and to work with our students, which are the software Arduino, which is the original software in order to, just one second, please. Okay. So what we will be exploring here is the software, which is the Arduino software, and we have the Tinkercad that I'll be showing you in a while. So where we have to create. So I'll move to this part directly because I'm going to show it to you live, not in this form of the PowerPoint. So I will move now to the okay. Is there any question till now, or it's okay, I can move? All is clear?
Yes, it's clear. ما عم يمشي عند الفويس، ما بعرف لك.
Okay, it's okay. Great. So when I first of all, I will move to the Tinkercad platform,
It's
which
on
is
website ولا
no,
application؟
it's till now it's an online application. We don't have the setup or the offline version of it till now.
اوكي، don't worry.
Okay. So
ندخل عليها ولا no هلا؟
no need to move هلا. Just يعني watch the presentation. So once I log in, and here if I go and I log out, you have like to log in or to create an account. So I advise you to go for the personal account and to choose from your personal email or a Google Mail or an Apple Mail, depends what you are using for. So it's a free access to this platform. And once you log in, you have three options to manipulate, which is or you create a 3D design, or you go for a circuit, or you go for a code block. Today we are going to explore the circuits, which is our main subject for today. So the moment the platform opened, you can see that on your right, you have only two microcontrollers available on this platform. And as I told you before that uh, in the world, we have only two leading microcontrollers, which are the Arduino and the microbit. So I will move the microbit, sorry, the Arduino board, and I will move my my breadboard, because this is the two main items or parts that I'm going to use in order to manipulate any project in Arduino. And you will see how it's going to facilitate a lot the process, because it is similar to what you are going to manipulate as hardware. So once I take my Arduino board, I can see that I have a connector for a 9-volt battery in case I want to connect my Arduino board to a power to make the project function away from my computer. So here you have the 9-volt battery. Here you have the USB port to connect it to the computer. And up you have like pins. As you can see here, you have digital pin 0 up till 13. You have the ground. You have down two grounds, one 5-volt, one 3.3 volts, and you have analog pin. And if we try to read a little bit the description of all those pins, we can see that they are digital pins. Here we have analog pins, and here we have power pins. This is what you have to know about the Arduino board. Actually, the IO ref and the reset button, or the VIN button, or here the A ref button, we don't have to worry about this. When I move to the breadboard, which is, it is compared to the wire, the socket wire, where we can plug many charger and many cables for laptops and computers and other. So here the breadboard is similar to the socket wire. So we can see that if I place my mouse on one of the dots up here or here, all the dots are connected horizontally. Okay? And if I go down, it's almost the same. But if I go inside the two sections which are inside here, I can see that dots are connected vertically, and here dots are connected vertically. What I mean by connection horizontally or vertically, simply it's like if I take like the ground button here and I plug it in this hole, automatically all the dots here are connected to ground. So it will facilitate my building circuit process in order to put on the breadboard many items at the same time. So now if I go and take one LED, and as you can see, the LED has two legs, which are the cathode and the anode. So it's simply, I can take my LED and place it wherever I want on the breadboard. And the cathode, which is the shorter leg, it will be connected to the ground. So I can take a wire from here till here. And then the other leg, which is the anode, I can choose any of those buttons and I can connect to the anode in order to create my first circuit. Just 1 second. Okay. So here, what I'm showing you is how to build a simple circuit by inserting a small LED. And imagine that I am going to let's say, to program this LED in order to start blinking. So if I click on code here, all right, and I can see that the programming is with blocks, not with C++, which will actually simplify the task for students. And I believe you agree with me. So here, by default, you will be surprised that in the forever loop, you have already 4 blocks. If I click on Start Simulation, I can see that the simulation started, and I can see here that I have a small LED blinking, and blinking with a delay of 1 second. But this LED is not blinking because it's connected to the pin 3, and in the program, it does not exist inside. So what I'm going to do here, I'm going to add the set pin, set pin 3 to high, wait 1 second, and then set pin 3 to low, and then wait 1 second. And if I click on Start Simulation, you can see that the LED is blinking. You have this LED is blinking, which is the LED 13, and here it's on pin number 3. Why I said that it's on pin 13? This is how the Arduino is made. I mean, if you link now, look what I'm going to do. I'm going to take a LED. I will connect the anode to 13 and the cathode to this row. And if I click on start simulation, so you can see clearly that this LED and this LED are blinking together. What we can conclude from this demonstration is that the address of this LED, which is a built-in LED on the board, it's for the address 13. So I'm going to delete it now. No need for. And as you can see, I can, if I want to control only the LED number 3, so I can remove all this, delete this, and then I can make it here like for 0.2, sorry, 0.2 by 0.2. And if I click on start, the blinking will be faster. Okay, so I can stop my coding. So now you saw that how the process of building an Arduino circuit is not complicated at all, because we are visually building our circuit, and then we can move to what we call the C++ translation of this code in order to copy it on the Arduino board. And by the way, here we are going to deliver you some hardware in order to explore them with your students. So the moment you receive the hardware, we can move and explore more and more any problem that you may face while manipulating the hardware. So for the time being, we will be limiting our demonstration to this simulation. But if I click on code, just follow my steps. Here, it's the block coding. If I click on the drop-down menu, I can see that I have an option for blocks and text. If I click on block and text, so look how the blocks are automatically translated.
Okay.
Yeah.
Again, that's so easy.
It's really easy. It's really easy.
It's copy paste to the main
exactly.
program.
So you copy, you go on the Arduino project, and you paste. It's really easy for you to manipulate.
طيب, we have something. What's the difference between the digital and analog? متى بنعوز الانالوج هي؟ الديجيتال قصدك عن السكرين وهيك بازرز ولا الانالوج شو هو؟
بس يلا ثواني. الانالوج وقت يلي you will be using the analog pin when the sensor is ready to read various values. The digital pin will read only value
Number
0 or 1.
1. Yeah.
But the analog pin can read from 0 to, I think, 255. I think, I'm not sure, I forget the value.
Yeah, because all of them, they are 256.
Exactly.
So you'll start from 0 until 255, yes.
Yeah, yes. So imagine if you are using a water level sensor or a humidity sensor. So the values this sensor is reading will be according to a set of values. It's not 0 nor 1. It might take different values between 0 and 255.
Okay, thank you.
So for LEDs now, we will be using the digital pin, and for the analog pin, we will be exploring them. In all cases, if you go over the 01 book, you can see that it's really well shown and well explained as a manipulation. Okay. So so here I can go for the code C++. I can copy and I can upload on my hardware Arduino board in order to see the manipulation working in a clear way. Okay.
اوكي
Other question or till
يس هلا بالهاردوير مش لازم يكون عندنا more than one wire لانه هي بقى only ground you should to give positive صح ولا لا؟
but the positive you took it from pin number.
اوكي here we take the wire اوكي خلاص تمام هي فكرتي بس.
اوكي شفتها هون.
اوكي يس خلص بياخذ من هون لانه تحت انا مثل ما قلت لي هي قلت لي في 3 فولتج و5 فولتج ذات واي انه علق براسي.
هو اذا if you take 3 voltage من هون you cannot control it by the program. يعني it will be on always. It will be on always.
اوكي on off صح فهمت عليك.
Okay, but sometimes like the servo motor راح فرجيك عليه السيرفو موتور لك وينه
فهمت.
خليني بس فرجيك السيرفو موتور يحو this one. Okay, this is a servo motor. So you have 3 pins. You have the signal,
Yes.
Yeah.
you have the power, and you have the ground. So logically speaking, you connect the ground to the ground. You can connect the signal
Yes.
to to the signal, and you connect the power to here to 5 volt.
For the power here.
لانه هيدا السيرفو موتور it needs power in order to function, not like the LED. Okay. If I move the ultrasonic sensor, لاحظ معي في عندك ground, power and signal.
Power okay signal yes.
يعني on each of the tools that you are using إذا شفت 5 volt أما 3.5 or power, it needs like it means like you need to connect it to the power which is here 5 volt or 3.5. راح فرجيك شو اسمه السويل مويستشر سنسور. هذا it will measure the soil of the humidity of the soil. اوكي بنشوف عندنا باور مرات بتنكتب VCC. ها
yes
عندك جراوند وعندك شو signal. alright. so على طول وقت يكون عندك 3 pins logically speaking بتكون انت بحاجه لباور.
signal already هي معطيها 3 or 4 or 2.
Exactly, depends from the hardware that you are using. Okay, so هلا practically what I advise you how to start with your students in a safe way, not to make them يعني not to accept this subject is to go through the introduction I did at the beginning and to do like a dialogue or discussion between you and them, and ask them too many questions regarding IoT, regarding machine learning, regarding sensors. Okay, why not to ask them to do a research about this topic, and when you finish this introduction, you will move to Tinkercad to show them the different elements of the board and the sensors and how to program. And when you feel like they are ready to start with the hardware, so you can give them the minimum hardware they need, not all the box, including all the sensors, in order to make them practice within a group of 2 or 3 students the projects in real. Okay. and
يس اول شيء بنبلش سيميليتر صح معك حق.
بالاول اكيد لازم تبلشوا سيميليتر. اوكي. بس in parallel, the moment you have the hardware, it's very important for you to prepare the circuit as a demo kit. يعني انت كأستاذ, you will prepare this demo kit, you will put it on your desk in order to tell students that the simulation that they are doing, okay, it's a real, and if we upload it on a hardware, it will function normally. I don't know if you got the idea.
Yes, I got it. Yes.
Okay. هلا,
Yeah.
if I want to move further to sorry, if I want to move further with my presentation, it's very important once you start with one LED, to ask them, let's say to insert another LED and to connect it to let's say to another pin like the pin 6, to take from the ground and to change the code here in order to make the both LEDs blinking like here and here. And if you hide and start the simulation, you can see that it's okay, fine. Then you will ask them, how can I turn on and off the LEDs at the same time? So easily you can move it like this.
In one loop.
Exactly. So hon it's about scenarios. Okay.
Yes.
And once this exercise is done, you are asked to introduce the resistor, and it's very important to make students understand the role of a resistor. And here I'm asked to turn my resistor, okay, to set my resistor to 220 ohm, because it's the value of the resistor I'm using to protect my LED. Because when I press on the simulation without the resistor, you can see that you have an exclamation mark. Okay. And if you slow down the just 2 seconds. Okay, look here. Okay. Sorry. Okay. You can see that there is a message, but it goes directly that the current is too high. It might broke the LED. That's why students must understand that they have to protect the LED using a resistor. So how to do this? Sorry. How to do this? It's very easy. So I will delete my okay. So I will go for the resistor. I will place it like this. And since this column is connected, okay, the wire will go and the current will flow on this other column. So if I go for the LED or for the digital pin 6 and I place it here, so now if we are going to explain for students why we have changed the circuit in this way, so we can tell them that the current going from pin 6 will go through this column, and then it will move through this resistor to this column with a low current in order not to burn the LED. So if I click on start now, you can see that this LED shows the exclamation mark, and this one, it's not showing because it's protected right now.
More, yes, sir.
Okay, so for the coding, nothing will change, huh? I mean,
Yes, no, yes.
just by adding the resistor. And another major information that you have to take into consideration is the serial monitor. And by the serial monitor, sorry, when I click on the code, you can see down that you have a serial monitor, which is like a screen to read the status of any component connected to
The board
sorry,
connected to the board.
the voice is not clear.
You mean that the serial monitor is used to control everything that is connected to our board?
Not to control, but to read from the board any information.
Yeah, okay.
يعني I mean, if now I go through the variables, I will create a variable. I will name it a counter. Okay, and on the start, I will set my counter to 0. Okay, and I will, let's say, I will
Change the count.
insert the change counter by 1. All right, and
Yeah.
by the end of each loop, each turn, I will display as an output. So here I have to go for where is my print to serial monitor. I will not print hello world. I will print the content of the variable. Okay?
Okay.
All right. So if I click now on the start simulation, look now. 1, 2. So here I can count, or I can display the content of the variable. And if I want to, let's say, let me check if I can add the ultrasonic sensor where it is to measure distance.
It's done.
Sorry? Okay.
It's done.
So I will go for the ultrasonic sensor. The ground will be connected to the ground. As
Yes.
usual, it's easy. The 5 volt will be connected to the 5 volt, and the signal will be connected to let's say 5. Sorry, my circuit is not proper, but it's okay, fine. So
Yes, okay.
I go for the start for the code for the input, and here you can see that I have my read ultrasonic distance. Okay, so I can add it to with another. Let me duplicate this one, and in the input I will take read the ultrasonic sensor. Ultrasonic sensor trigger pin is like 4, 5, and the echo pin is same as trigger in unit centimeter. Okay, so I added here a print to read the distance for read by the ultrasonic sensor. I will start my simulation, and here, excuse me, and here, in order to activate the ultrasonic sensor, now it's not showing. Start simulation. It's showing 113 centimeters. If I want to change the value, I click on my ultrasonic sensor, okay, and normally this is my object. I can place it here. It will show now 69.7. If I place it here, 203. If I place it here, 283. So you can see that actually the serial monitor is very important. I will stop my simulation. I will take block and text, and look here how the code is generated automatically. And this will simplify you the task for explaining and showing for students. Okay? So what I ask you right now, Mrs. Randa, also you teach higher grades, no?
Really, I'm programming. Okay, I teach programming for 3 years maybe, but this year I teach only math, calculus, and algebra too.
You are not teaching. You are not teaching ICT.
No, I'm just coordinator.
You are
Coordinator for the computer teacher.
Okay, great. Okay.
At our school.
All right. So what I ask you, or you have to ask your teachers who are teaching, who are giving Arduino, is to watch this tutorial, to explore the PowerPoint I sent, and to go through the lessons in 01. All right. And the moment you receive the hardware, you'll try to practice in order to move the block coding to the Arduino and to test it with your students.
It's okay.
Okay, thanks.
For the next session, you think Sunday evening it's okay, or Saturday you think?
Sunday, it's better.
Sunday, all right. So كمان نفس الوقت الاتحاد.
اوكي شو رايك مستر رندا؟
It's okay محمد، ما عندك مشكلة.
لانه عندنا الخميس بيرنتس ميتينج.
يا الخميس بيرنت ميتينج
وخلينا نفتح مع سبت.
خلاص انا هلا بودي من بعد ما اخلص هلا.
انت الاحد على يور تايم. شوف انت متى فري، نحن الاحد بعد ما هم الساعه 4.
ايه خلص 5:30 ليك. رح طلع هلا الريكوردينج